Okay, in the last lecture, yesterday, we have finished doing this example. Now, today we have another example. Let's read. A radar installation transmits a wave whose magnetic field intensity is H equal to x multiplied H0 cosine omega t minus K0 multiplied by Z, where H0 is given, frequency is given, propagation is in free space, and Z is the vertical direction. Okay. Assume plane waves and lossless propagation, and we need to calculate the wave number for the wave and electric field intensity of the wave in phasor form. Now let's start by computing the wave number. Okay, the free space wave number is calculated from the intrinsic impedance of free space, which is known. So intrinsic impedance of free space is given as omega multiplied by mu 0 over K0, and the intrinsic impedance of the free space is equal to 377 ohm, which is a constant which we derived the last time, and from here let's find K0. K0 from here will be equal, K0 is the wave number, will be equal omega multiplied by mu 0 over eta 0, and which is in turn omega is 2pf multiplied mu 0 over eta 0. Okay, let's put the numeric values. If we put the numeric values, we have 2 multiplied by p multiplied, so frequency is 30 gigahertz. It means 30 multiplied 10 to the 9, and multiplied mu 0. Mu 0 is 1.27 10 to minus 6, or mu 0 can be written as 4p 10 to minus 7 divided by eta 0. We said eta 0 is 377, and wave number for the wave is, okay, let's compute, 2 multiplied by pi multiplied by 30 multiplied by 4 multiplied by again pi, so pi multiplied divided 377. Okay, we have 6.28 10 to the power of 2, or 628.3. So the wave number k0 in our case for this wave is 628.3 radians per meter. Okay, what about the second question? Second question is asking us to write electric field intensity of the wave in phasor form. So, okay, first of all, let me copy the H. So H is equal to X multiplied by H0 cosine omega t minus K0Z. Well, from the equations that we derived yesterday, or if I say more precisely, for example, the H y plus of Z was equal to 1 over intrinsic impedance multiplied by electric field intensity, in this case X, and from this relation we may say that from this relation we may say that the magnitude of electric field intensity will be equal, so eta multiplied by magnitude of magnetic field intensity, or eta, in our case, eta 0 multiplied by the magnitude of magnetic field intensity. And magnitude of magnetic field intensity in our case is H0, and H0 is given as, so H0 is given as 25 ampere per meter. Okay, 25 equal 377. This is the intrinsic impedance of free space multiplied by 25. And it is equal to 9,425. Unit of measurement is volt per meter. Okay, wave found the magnitude of electric field intensity. Okay, what about the direction of the electric field intensity? Okay, what about the direction of electric field intensity? So, in order to find the direction of electric field intensity, we use Ampere's law in lossless media and in frequency domain. So, what was the Ampere's law? Do you remember the Ampere's law? The Ampere's law was, so what was the Ampere's law? Ampere's law was states that rotor of magnetic field intensity is equal to J plus J omega D. So, as we are working in lossless media and in the lossless medium and in the medium without source charges and source current, J in our case will be 0 and rotor of H will be equal to J omega. What about D? D is equal to epsilon multiplied by electric field intensity, or in our case we are working in free space, it is epsilon 0 multiplied by electric field intensity. That's why we have J omega epsilon 0 the electric field intensity. Okay, now let's write this cross product and let's write this vector field E in terms of sum of components along X, Y, and Z. So this cross product gives us what? X d h z over dy minus dhy over dz plus y dhx over dz, yep, minus dhz over dx plus z dhy over dx minus dhx over dy and is equal to So we have written this in form of sum of components. Okay, now we need to write this also in the form of sum of components. So j omega epsilon 0 are independent of x, y, z. That's why they go out of the bracket. And here what we have, x component along x plus y component along y plus z component along z. So now let's look at our magnetic field intensity equation, which is equal to H is equal to X H0 cosine omega t minus K0 Z. So it means our magnetic field intensity has component only along X, which is Hx, and it depends on Z, Hx of Z. Okay. It means Hy and Hz are 0. Hy and Hz are 0. It means this bracket is 0 because they involve one of them involve Hz, another one involve Hy. What about second component? In the second component we have dHx over dz. So we have dHx over dz and dHz over dx. Okay, this one involves hz, which is 0. That's why this component is also 0. For now, we are not looking at dHx over dz. So let's move to the third bracket. Here we have dhy dx, which is 0. dHx over dy will be also 0 because hx depends only on z. It doesn't depend on y. So if components along x and z are 0, correspondingly components of electric field along x and along z will be also 0. It means we have only component along y. Now what we have dHx over dz will be equal to the component of Ey component along y. Okay, we know the magnitude of electric field intensity. We know the direction of that component. It means okay, it is directed along y. And now uh, sorry, here I have done a mistake, very awful mistake. dHx over dz will be equal to j omega epsilon 0 Ey. Now it's true. So in order to calculate this this expression, derivative of hx along z, first of all let's write our expression for h in phasor form. It means so h, it means h is equal to x multiplied by h0 multiplied by e to the power of minus j k0 z. And if we take the time derivative, or okay, let's say okay, let's go back to this expression. Sorry, I can't understand your question. Can you please write more detailed form your question? Well, let's go back to this equation, and if we let me write it one more time here. So d hx over dz will be equal to j omega epsilon 0 e y and from this we may write that ey is will be equal to 1 over j omega epsilon 0 dhx over dz, or the electric field will be we already know that electric field is directed in the y direction, y 1 over j omega epsilon 0 dhx over dz. Okay, now let's try to compute the derivative of hx with respect to z. What we will get? Okay. So if we look to the phasor form of h, this component is hx. So we need to take derivative from this with respect to z, and the derivative will be minus j k0 minus j k0 over j omega epsilon 0 h0 multiplied e to the power of minus j k0 z and multiplied the unit vector y. Don't forget about the directions and about the unit vector. And will be equal to j, and j simplifies, and we get minus y k0 over omega epsilon 0 h0 e to the power of minus j k0 z. And if we put the numeric values for k0 omega epsilon 0, what we get? We get minus y. What was the k0? K0 was equal to 628.3. Okay, 628.3 over omega was 2pf, or 2p, and frequency was, if I'm not mistaken, it was 30 gigahertz. Yes, 30 gigahertz. 30 10 to 9 multiplied epsilon 0 is 4p 10 to minus 7. Okay, multiplied. Now I'm not writing the, for now I will not write the numeric value of h0. h0 multiplied e to the power of minus j k0 z. Okay, can you compute this expression by your calculator? I will compute as well. Okay, if we look at it, 628.3 divided by 2 divided by pi divided by 30, yep, divided by 4 divided by again pi is equal 0.2653. Okay, 0.2653 10 to the power of minus 2. Okay, or 2 point, so we have minus y multiplied 2.6525 6525 h0 multiplied e to the power of minus j k0 z. And Sorry, I forgot the power of 10. And if we write the power of 10 as well, okay, 2.6525, 10 to the power of minus 3 multiplied h0 multiplied e minus j k0 z, and now is equal to minus y multiplied to 65 25 10 to minus 3 multiplied h0 was 25 ampere per meter. Yeah, yes, 25 ampere per meter multiplied e to the power of minus j, k0 is 628.3 z, and let's compute. Stop, please. Well, I did a very rough mistake, sorry, because epsilon 0 is equal to 8.854 10 to minus 12, but here I wrote another thing, 4p 10 to minus 7. It is not correct, and everything is not correct. Sorry, let us compute it again. Okay, let me go to a new page. Okay, is equal to minus y multiplied k was 628. It's okay, it is okay, 628.3 divided by omega was 2 multiplied pi multiplied frequency, and frequency was 30 megahertz multiplied epsilon 0 is 8.854 10 to minus 12, and multiplied h0 is, let me write, 25 e to the power of minus j k0 z. Okay, let us compute one more time. This time I think we will not do mistake. 628.3 multiplied 25 divided by 2 divided by pi okay, divided by 2 divided by pi divided by 30 divided by 2 pi 30 and 8.854 equals 9,411 or 9,412. Okay, let's double check in order not to mistake this time also. Okay, multiply 25 divided by 2 divided by pi okay, pi divided by 30 8.854 okay 9,412 9,000 equals minus y multiplied by 9,412 multiplied by e to the power of minus j k0z. Now it's correct. Okay, we found the electric field intensity in phasor form. Equals to this. Okay. Okay, we may write the electric field intensity equals to minus y multiplied 9,412 multiplied by e to the power of minus j. K0 was 628.3 Z. Here we found the electric field intensity in phasor form. Now, do you have any questions regarding to this problem? If you have, ask your questions, or if you don't have, you may have a rest.